All right. Well, that sounds promising. Let's see that. Right. AI note takers. Big debate about deepfakes in Germany at the moment. A big demonstration. I'm in Hamburg at the moment. It's a big demonstration starting in 4 hours. And I guess having the lawsuit in California being resolved kind of puts more oil into the fire. Right. I think we're on the hour. All right. Well, I think it's time to start. Welcome everyone to this webinar. And it's a great pleasure having so many of you. People are still joining. So we're giving it a small moment here and to let everyone get on. But just to say welcome, my name is Matthias Holweg. I'm the American Standard Companies Professor at Saïd Business School at Oxford, and very much involved in providing our AI programs. And you may be aware of the Oxford AI program or the Ethics Regulation Compliance program, which are two amongst the many. And of course, I'm joined here today by Mike. Mike, you would like to say a few words?
Well, my name's Mike Wooldridge. I'm an Ashell Professor of the Foundations of AI here at the University of Oxford. And I've spent my entire professional career working on AI, and in particular, agentic AI, as we're going to hear about today. And I've been working with the business school on establishing their executive education programs. And I know many of you will have sat the AI executive education programs that I was involved with Matthias in setting up back in 2017 or so. And we're very excited about this new opportunity to tell you about the latest generation of AI. And it's something that I spend my working life on. I'm really excited about communicating what it can do and how you can beneficially use it.
Yeah, right. Well, and from a business school point of view, of course, agentic AI is very much at the forefront, of course, because of its potential to automate a lot of business processes. This links up to many broader questions of the future of work, of what does it mean to add value, and how can we implement AI in a safe way. But let's start at the beginning. First things first, like you said, you've worked on this for decades. I have not. I've already come to this probably within a decade or so. And of course, agentic, the way I see it, is very different from the way that you perceive it, having worked on this for 30 years. Please, start if you would you mind sharing where does this all come from? What are some of the intellectual origins?
Well, it's, as you say, it's not a new idea, agentic AI. It's been with us, in fact, since the 1980s. And the idea of agentic AI right back then was to change the way that we interact with software. When we interact with software at the moment, even today, most of the software that we interact with, anything that happens because you make it happen. You press a button, an icon, or you select something from a menu. You're driving the entire interaction yourself. And the idea of agentic AI that we had all that time ago was that why should software just be the passive recipient of our instructions? We should have software which cooperates with us, which is like an assistant, something which is working on our behalf. And the name that we coined to describe software like that was agents. Now, I say I've been working on that dream for 30 odd years, but the truth is to make that dream a reality, to build really, really useful agents, what you need is the AI that we have today.
Yeah. And quick point. Thanks, Carlos. I just switched microphones. I hope the sound is better now. Quick answer would be appreciated. Um, so what are the key achievements then, Mike? What have we got today before we get into all the LLM-based agents? What sort of were those of the key highlights? And I remember you pointed me to this one video about the intelligent assistant. I think it was an old Apple video, isn't that right?
Yeah, so there's a range of different capabilities for AI agents, and you're gonna if you sit the course, and we very much hope that you will, you're going to hear about that full spread of capabilities. But it starts from agents which are essentially just empowered, knowledge-based, empowered chatbots. So you give them specialized knowledge. For example, I'm based in a college in Oxford, and we might give it information about that college, and then the AI trains itself to be able to answer questions about that. So here, it's just kind of a chatbot, but a specialized chatbot. And as you'll see in the course, we can very quickly build and deploy agents like that that are really, really useful, and that can be incredibly powerful. The next step up from that is agents that carry out parts of your business workflow, agents that are chasing up a series of actions, one after the other, where the actions are things like send an email to somebody on this topic, wait for the reply, and then based on that reply, decide what to do, where AI is actually driving that process, driving that workflow. So it's not you that's doing this. It's like you've got an agent, an AI agent working alongside you. And then the step up from that, where we're right at the cutting edge of capabilities right now, is the agentic organization, where you have humans and software agents that are working alongside one another. And then beyond that, you've got the dream. Microsoft had talked about this recently, the idea of the agentic economy, that where the economy is going to in the future, where the world of work is going to in the future, is a pool of laborers that are buying and selling things, products and services, where those laborers are AI agents as well as human beings. And that may sound fanciful to you, but that is the future that's coming. It's going to come, and it's probably going to come faster than you expect it to come. And again, this is all stuff that we're going to talk about on the course.
Now, why hasn't it happened before, though? I mean, obviously, good old-fashioned AI tried to learn, through symbolic AI, tried to learn the rules, and we embedded those in expert systems. They never really got there, did they? I mean, my career sort of in IT systems supporting operations started in the 90s, and I was just at the back end of people getting very frustrated and disillusioned with expert systems. I'm sure you spent quite a bit of time more on those. Why did they never take off?
The idea was right. The technology just wasn't powerful enough. And what we've discovered, and this is one of the big discoveries of AI in the last 20 years, is we're in the scaling era of AI. And what we've discovered is actually, if you take neural networks, which is a very old idea in itself, inspired by the neural structures that you see in the brain, if you take neural networks and lots of computer power and lots of training data, then actually that's enough to deliver you very, very capable AI. Now, the amounts of training data you need and the computer power that you need to build that kind of AI is astronomical. It's genuinely hard to get to grips with just how much computer power you need to build a ChatGPT type system. And that just wasn't available. Even a decade ago, that kind of the scale of that data and the scale of the computer power that you need to build capable general purpose AI just wasn't available. So the ingredients have just come together in the last decade, and the magic ingredients are, AI technologies which by themselves are not that new, together with large scale data and enormous compute resources. Put those three together, and what you get is something really remarkable. And what that enables is things like AI agents that can now very well understand ordinary language, like the conversation that we're having now, something that we take for granted, but which was phenomenally difficult to build in AI terms. And we didn't have that available even 10 years ago. This has only been enabled by those magic ingredients, new neural network architectures, data and compute that came together. But we now have AI that we can communicate in a very natural, very ordinary way to, you don't have to be a computer programmer to use ChatGPT. And that's one of the important lessons of our course, right? That anybody can use this technology to empower them. So you're getting this incredibly capable AI, which is being driven by natural language, just being given instructions in ordinary human language. And that, if I had to identify one reason why this old dream of agentic AI is just coming real now, it's that. It's because you want AI to work alongside you. How are you going to tell it what you want it to do? Human beings do that by ordinary language. And we just didn't have AI that could understand ordinary language until very, very recently.
Yeah, and I think it's not, we can't overstate the importance of it, right? I mean, 10 years ago, we were playing around with recurrent neural nets, and machine translation was, poor at best, mediocre if you were really lucky, and generally very specific to a given problem, but certainly nowhere near the universal way in which we can speak to a computer now. And I think I think you put it nicely in as far as that the LLM is the key enabler of what we now call agentic, right? Which is actually a very different form as to what agents used to be like. And the ability not just to interact with them, as in try and task an agent, but also to program it, right? And of course, those of many, I'm sure, on the call will have played around with low-code solutions like Copilot Studio, or tried a bit of vibe coding. That's of course all only possible for two reasons. One, the vast amount of training data, meaning it's seen tons and tons of lines of code before, which is a nicely structured data set in many ways. And then the ability to extract from our prompting and the context window as to what the task actually is. And I think that is, if we were to put it down, right, that is the revolution as to why, in fact, why we're having this course now, right? Because this, in our view, is going to fundamentally change the world of business, because many of the repetitive tasks, and I always say, humanity is not very good at admitting that a lot of things we do does repeat, and the minute it does, even within some bounds of variation within that task, it actually becomes automatable. Or the more it repeats, the more standard it is, the more economical, I should say, it is to automate. Right? We've always have been able to automate it, but the economics of it generally didn't work out and I think that's one of the reasons why the expert systems actually failed. But let me ask you this, and this is something that I was curious about. I mean, there's been a lot of talk about the LLMs, of course, that we have essentially are sort of based on system one type of thinking, right? They shoot, based on a prompt, they do next token prediction. They don't think, right? They simply, assemble statistically what's the next word that should be in the response. What's your take on, chain of thought and knowledge graphs and, multiple models in order to improve the reasoning abilities? I'm just curious.
Yeah, well, I think you're putting your finger on a really interesting point, which is the way that large language models work is really remarkably simple. All they're trying to do is, based on the incredible amounts of training data that they've been given and the prompt that you give them, the text that you type, like a one paragraph summary of the life of Winston Churchill, like that might be a prompt that you get. All they're doing is guessing the likeliest next word that should appear based on your prompt and the training data. The scale of them, the scale that we just talked about, means that they can be remarkably good at doing that. So, the training data for a model like ChatGPT will include essentially everything that's on the World Wide Web. And so lots of biographies of Winston Churchill. So it will turn out to be very good at producing, a one paragraph summary of the life of Winston Churchill. But one of the big questions we have, and the brightest minds in AI argue about this, and they argue about it a lot, is it doing anything deeper than that? I mean, is this real intelligence, or is this just the appearance of intelligence? And we don't know, is the short answer. But one of the really interesting developments recently is the idea of instead of just having a model that produces an answer, immediately produces it, get it to iterate over that answer, get it to think about the answer. And I'm putting quote marks around the word think because AI people don't like to call this thinking. It's not thinking like we're thinking. But you can, with some models, you can actually watch what they do as they think. You can watch the conversation that they're having with themselves. And this is called chain of thought reasoning. And it looks very much like you're having a window into the kind of the mental conversation that the AI is actually having. And the remarkable thing is, by forcing the model to spend more time doing that, turns out we very quickly get much higher quality responses. We get chain of thought reasoning systems that can do PhD level maths problems. Not perfectly, they're full of bugs, but actually I have to tell you, all mathematicians are full of bugs, right? They have to iterate over their proofs and their solutions, and they make mistakes, and the first draft of what they do, contains a mistake, and then they iterate over that and so on. Famously, like Andrew Wiles here in Oxford developing a proof of Fermat's last theorem, 300-page proof or thereabouts, and famously his first iteration of it contained a bug. It took 2 years to fix it. So they make mistakes, so do human beings. But this process of iterating over the answer, and I say watching them at work doing this is kind of uncanny, and it's easy to read too much into that. And we talk about that a little bit in the course. But nevertheless, the output is something that's really quite surprising, particularly when you get to writing computer code.
Yeah. And I think we should just maybe briefly refer to two papers, at least that I like a lot, which is the both by the Apple Machine Learning Lab, one GSM symbolic, and the other one the illusion of thinking, right? Both of which very much underpin what you just said about chain of thought reasoning, right? That is, that the fundamental mechanism of a prediction hasn't changed. What does change, however, is the complexity of the task. So rather than prompting for one big task, which requires a lot of sort of filling in the blanks, right, inferring what may be needed, breaking down the task and taking out is potentially redundant prose, which is the GSM symbolic paper, of course. Those of you interested will find it quickly. Shows that having redundant prose throws off the prediction quite nicely. Equally, the illusion of thinking paper that shows that for complex tasks, most models still fail, yet for smaller tasks, the chain of thought models, sorry, for moderate tasks, the chain of thought models outperform the straight prediction, next token prediction models quite a bit. So in that sense, I think, the chain of thought is bound to improve, right? Because it does break it down. And personally, I don't know if those of you who've played with it, with Gemini, I do like that I can edit the chain of thoughts, right? And to actually correct the steps. And essentially what of course you're doing is for each step you are, you have a query. So my question, in fact, I don't know, I'm curious to your thoughts on this. Would this also mean that chain of thought prompting increases the energy consumption of the single prediction? It's bound to be, right?
Yeah. And the early reports were quite startling, actually. So there was, I think it's now 2024, when we saw the first models, the O1 model that came out from OpenAI that did this. And kind of just an observation they made is you're now getting the AI to, because you're getting it to think a lot more, that AI is not running on your laptop, it's running in the cloud. And what that means is it's running on supercomputers that are somewhere probably in a data center somewhere in the United States or somewhere else. And these are AI supercomputers that are really sweating over producing the answers to you. So it was always expensive to run AI, but now they're doing an awful lot more work. And in the early models, the estimates were for some of these maths problems that were being given, it was like the compute cost, which means the energy costs really, were up to $1,000. So firstly,
Oh.
that's very expensive. And
Mhm.
secondly, that's energy that's consumed. That's actually a lot of CO2. So there's a huge amount of work now on trying to make this whole process much more efficient. but it still is expensive. And I say when you use AI, you have to remember it's not running on your laptop; it's running on an AI supercomputer on the other side of the world. And so you've got to be, you've got to be mindful of that. Think about the casual queries when you're asking it to compare the performance of Liverpool Football Club and Man United. That casual query is making an AI system on the other side of the world sweat, use enormous amounts of energy, and generate CO2. So
Yeah.
this is one of the trade-offs. You've got to think when you're making this work for you, you've got to think about those value trade-offs. They're very important.
Yeah, I mean, that brings up a question I get a lot actually, which is the idea that the AI bubble essentially is largely fueled by companies providing these models below cost in order to capture market share, to create lock-in. And of course, that if those services were offered at cost, most likely we would probably think twice, as to whether we do need, the flagship model and the deep thinking mode, or whether
Exactly so.
a small language model might actually be preferable. So let me ask
Yeah.
you, so on the AI bubble, I'm sure you get the same question as well. What's your take?
Well, it's firstly, it's an interesting point you make about the large models versus small models. I mean, when you talk to the flagship models, the models that the companies are most proud of, the ones that are trained on, 40,000 AI supercomputers running for months, which have just a development cost that runs into hundreds of millions, if not billions of dollars, and that's a very real estimate of the cost of these things. You're getting an awful lot of power, but do you need all that power? Could you actually get away with something that was, maybe not quite as powerful, but enough for your task? And so an awful lot of the business tasks that you might want to use can actually be carried out by what you mentioned, small models. Now, small models are so cool because they're not as big and powerful as the state of the art chat GPT and so on. They're small enough that they could just about run on your laptop, and you need quite a high spec laptop to run on them, but nevertheless you can run on your laptop. Now, for various reasons, I use them. So, for example, one reason that you might want to use them is you don't want to upload your data to a data center on the other side of the world. If you've got some private application, you want to keep that data local. And so running a small model on your laptop is the way to do it. But actually, if I'm sitting on a train running a small model with my laptop on my lap, I can feel my laptop heating up,
Yeah,
and I
yeah.
can watch the battery sort of indicator, go down. You really get a sense of just how much power is being consumed by them. So even the small models are actually expensive to run.
Yeah.
So is there an AI bubble is a really good question. And the question is, so much money is being thrown at AI by the big tech, what are called the Magnificent Seven. That's Google, Microsoft, Apple, Amazon, Meta, Twitter, whoever it is. The big seven. I forget. You can remind me who it is, Matthias. I'm sure you've got it. I'm sure you've got it on there at
Or did you forget
your
Meta?
fingertips. The big seven tech giants. They're spending trillions of dollars on AI. Awful lot of money is going to data centers to make it possible to run this AI. The good thing about that is that's bringing the cost of computer power down by providing data centers at scale. It's getting much cheaper to provide computer power, so that's good. But the big question is, are they going to make enough money back from this to justify that expense?
Mm.
And this is quite literally $1 trillion question. My guess is what we're going to see is what you and your friends in the business world would call a market correction. I think so much money is being spent that it's not all going to be recouped. But when the dust settles after that, so look out for the headlines over the coming months. The scale of investment, it's hard to see how that's going to be recouped in the short term. But this technology isn't going away. This is incredibly powerful and useful technology. So it's not going away. It's going to be with us. It's going to stay with us, and it's going to remain very powerful.
Yeah, no, I actually answered generally the same way, that I'm not an economist, and I don't follow the stock market after having burnt my fingers in doing it badly through the various crashes. I leave this to professionals. But my answer from an operations point of view is exactly this, that where it does show its value, and it reaches, in the hype cycle, the plateau of productivity is bound to stay because it's clearly shown that it's technically feasible, it's economically viable, and it's socially acceptable, right? So it meets all three criteria for a technology to be adopted. And that's the point, right? Those jobs that have been affected by an AI agent being able to do it better, and I generally use the rule of 10, right? 10 times faster or at a tenth of the cost. Um, uh, it will not come back, right? These jobs will be gone. And I think this is sort of the fundamental driver, behind sort of this entire future of work debate. I think there's two strands to it, and both of them are relevant in this context, particularly with regards to agentic. Number one, that pretty much all jobs will be augmented by AI in some case, meaning that a job consisting of many tasks, some of those for sure will be augmented. But those that are entirely automated away are unlikely to return, right? And I think that's where the future of work debate is very prominent with regards to generative and agentic AI, right? As to which processes agents can do now reliably, economically, and governed to a degree that we're happy for them to do it, right? You mentioned earlier AI agents linking up to other systems, right? That throws up a lot of governance questions, right? Do you give your credit card details to OpenClaw or not? Very specific question. I'm debating at the moment.
Yeah, right now I wouldn't recommend that at all. The one of the worries about agentic AI is that the whole point of it is you have AI which actually does things for you. And because it can do things for you without necessarily asking you if it gets things wrong, and we know AI gets things wrong, and this is one of the things that we talk about in the course, of course, the way that it gets things wrong. You give it a credit card number, it can do dumb things with your credit card number. And so, understanding what is a good thing to get your agent to do versus not a good thing is really one of the important challenges that we face today.
Yeah, and it's an active area of research that we're working on. We're developing, compliance protocols for agents. And so that basically means we have to look at all attack vectors, right? From simple misalignment, meaning it does something it wasn't meant to do, but no one tried to do anything bad with it. It simply had either set, wrong objective functions, or it hallucinated and it wasn't caught and simply did stupid things. To malicious prompt injection, right, where essentially someone might simply try and get the agent to do things that are beyond its remit, and the guardrails are in place. To outright control issues such as uncontrolled proliferation, uncontrolled learning, right? Probably one of my biggest concern. I don't know what you say, but I mean the three biggest concern I would have with agents is number one, access to critical resources, to which I would include my credit card, although that's probably quite a personal problem. But in general, right, AI systems gaining control of critical infrastructures. Secondly, I would say AI systems that are able to copy themselves, meaning proliferate without control, which means they essentially become eternal. And thirdly, if AI agents were to learn at a rate, or AI systems in general doesn't need to be an agent, right? Any AI system learning in a way that we no longer are able to replicate or understand how and what it has learned, right? Now, you probably will turn around to me and say, look, open up a neural network. I mean, what do these weights and parameters tell you? And I would probably say nothing, but at least I can structurally or logically understand how, a labeled data set leads to a change in parameters, through backpropagation, like. But yeah, those would be my three concerns. And clearly, with governance questions of agents, those are amplified, as you said, because they are gaining autonomy in the sense that they, no longer have a human in the loop, but of course a human on the loop only, meaning that the individual decision is not verified by a human. But I don't know, what are your sort of main concerns with the brave new world of agentic that's coming?
Well, I think I'm not worried about robot takeovers. I mean, there are lots of things in the world I worry about, but robot takeovers is quite far down my list, to be honest with you. It's there, but it's just not very high on the list. So that's not something I lose sleep about. I think there are, for example, the one thing that's concerning is, if everybody can build an army of AI agents to work on their behalf, then the world is going to get the online world is going to get very crowded, and it's going to be quite hard to figure out what's human and what isn't. And I'm not sure that's entirely healthy. Um, there are Governments have concerns, very legitimate concerns, I think, about the idea of, this technology is very empowering, but it's empowering bad people as well as good people. And so they're worried about, as we head into elections, having armies of AI agents spreading misinformation. That's one of the things that they worry about. So those are the kinds of concerns, not sort of robot takeovers. I'm not losing sleep over that.
Yeah, neither am I, but I do lose sleep over the polarization of public opinion, right? And that's where the lawsuit that's just been successful in California, I think very much shows that the design of the AI system, in this case the content recommendation algorithm, has an impact on people, right? And in this case, on the time spent on the device or on the platform. But equally, right, we know that the very same recommendation algorithm works by essentially exploring your preference, meaning showing you more of the content you like, and sorry, exploiting your preference and then exploring very little, right, in order to just keep you hooked with new things. But in essence, essentially reinforces your known preferences, meaning you get shown content of one side of the spectrum of, let's say, the political debate only, right? And that, of course, leads to the polarization that regulators rightly worry about. So I think in that sense, I'm hopeful that at least these topics, get out into the open. The big deep fake debate, of course, that's raging at the moment here in Germany, where I'm currently at, and Spain, for the obvious high-profile case being discussed. But it leads to a general problem, right? That is about 50%, and there's some cool studies on this. 50% of all text written on the internet has already been touched by AI, right? So you mentioned, what is real? I think on the internet, you should already assume that it probably isn't. And latest figure
Yeah,
actually,
and
yeah, go on.
yeah, particularly the kind of slop that we see on social media, where you've got, some original story which is then rewritten by AI, and then 20 versions of it appear, and then AI gets those 20 versions and generates another version, and so on. That's not something that I take a great deal of pleasure in. But one interesting side effect of that is we're going to a future where human generated content, actual human generated works of literature, art, and so on, are going to be prized. They're going to be particularly prized because they're not the slop. They are art which has been generated by people who've actually had the feelings that the art is representing. So. It's going to be a different world. I mean, I think the optimistic version of this is that AI becomes another tool that artists and creative people can use, and it will, for example, in the news sphere. I think if we think we get a lot of news content now, we haven't seen anything yet compared to what's coming. The AI generated news that's coming is going to be on a different level. I mean, and where the news is, it's like you're going to be reading a newspaper which is tailored specifically for you, for your interests, for your tastes, for your social background, for where you live. Something which is, so the world perspective that you see through AI is going to be tailored specifically to you. So there are upsides, but I say, the AI slot world, which we're running to very, very quickly, is not one of the upsides.
Yeah, and of course the AI slop also has technical issues, right? Regardless of whether you like it or not. And by the way, on the customization, the idea that I would go through and then create pictures of what your children would look like in the latest fashion offered by company X, of course, technically is very, very feasible, right? So I think you painted a nice picture there of a positive side effects. I can see also some very intrusive and manipulative techniques there to say, look, this is what you or your children or your loved ones would look like in a certain product. But just to come back to the slop also has a technical aspect to it, which of course we should mention, right? And this is the paper by Yaron here at Oxford and colleagues on model collapse. That so far the assumptions and GPT-6 was mentioned here in the questions. I'm just browsing, the general assumption has been we increase the training data, we increase the compute by a factor of 10, let's say, from generation to generation, and we see an increase in model performance. I think those days have gone, quite frankly, because we've exhausted all available training data publicly available. And you could argue that all the lawsuits on intellectual property right infringements already sign that we've gone beyond what is available or legally accessible. And of course, what happens is if we keep using AI-generated data, we're essentially feeding AI its own soup, and that will then lead to over generations a regression to the mean, meaning you just keep pulling from the center of the distribution, and essentially you have like AI-based inbreeding that leads to a collapse of the model. Now, some arguments have been brought forward as to say, yes, you can show this by using the same model and training it on its own generated data, and it will collapse. But here we have many different models trained in different ways, and humans still meddle with the content. So I don't think the model collapse is imminent, but personally, I would not expect GPT-6 to, as and when it does come, to significantly outperform what we currently have with current models. At least I wouldn't. I don't know what you feel.
No, it's interesting. So the release of GPT-5 last year, 2025, was the most hotly anticipated AI release of the year. And of course, OpenAI went out of their way to build expectations up about what it was going to be capable of. And some people genuinely seem to believe it was going to be AGI, the kind of, which is kind of like a holy grail in this space, rightly or wrongly. But actually, when it arrived, the interesting thing about it is GPT-4 had been capable of things that no other AI system had really been capable of. It was really fundamentally new. And similarly, GPT-3 it was a step change in capability over its predecessor. But GPT-5 didn't feel like that. I mean, it didn't, when you used it, it was good. It was clearly an improvement. But could you fundamentally do something that you hadn't been able to do before? It didn't feel like it. I mean, with GPT-4, the big innovation of GPT-4 was what's called multimodal. It wasn't just a text-based system. It worked with images. GPT-5, of course, did that, but we already had that, and it was better, but not as, it wasn't quite the same step change. And it seems like a lot of the improvements that went into GPT-5 were what we call under the hood. That is, they were about making the AI system more efficient. For example, by routing your prompt, your query, to engines that were more specialized to handle it at sort of more efficiently at lower cost and so on. So about providing a slicker overall service at a more efficiently by OpenAI. But we didn't see necessarily those benefits. So on the back of that, there was quite a lot of skepticism online. A lot of people were poo-pooing the claims for advances. If we saw a step change in capability in the way that we did with GPT-3 and GPT-4, then GPT-6 would be very impressive indeed. But I'm with you. I think probably we're not going to see. I think what we'll see is specific areas in which it gets better. And I don't know what those areas will be, but there'll be specific areas in which it will be better. But I don't think we're going to see massive leaps forward in intelligence. That's my bet at the moment. But then on the other hand, over the last 10 years, we've been surprised at how AI has advanced a couple of times. So it's not crazy that we should see similar advances again, but I wouldn't bet on it.
Yeah, and I'm sure Vaswani et al., right, the researchers that developed the transformer, were very much surprised by how their machine translation algorithm suddenly, was at the heart of this latest revolution, so to speak, in AI, right? Which they didn't foresee, and no one else did. And I'm like you. I look at, and we can talk about new architectures in a second, right? Or what's coming. I would not make any predictions whatsoever. But before that, and I know you don't like talking about it, but there has also been a question on GPT-6 and AGI. How would you even define AGI? So artificial general intelligence, right? If you were to put a definition to it.
Well, so this is one of the Silicon Valley buzzwords that, 20 years ago was not a mainstream idea at all, but it's become mainstream. And basically, the idea of AGI is that you have AI which is as capable as a human being. Um, and uh, and what that might mean for GPT-6 was that if GPT-6 achieved AGI in its area, then it would be capable of doing anything that a human being could do via a conversation, via a chatbot type interface. In other words, any task that you could present to a human being via a chatbot type interface by typing something to them and getting a response in the way that you get responses from ChatGPT, we'd have AGI if GPT-6 could do anything that a human being could do in via such an interface. I think it's unlikely we're going to get that. But if we did, it would be completely transformative. I mean, it really would be. It really would mean that a huge range of tasks, which at the moment only human beings could perform, would fall under the capabilities of AI.
Yeah.
And one way to think about that is think about somebody who's working remotely, where you interact with them via email and phone calls and so on. You think about the jobs that are possible in that way. If we had AGI of that kind, then we would have AI that could do anything that such a remote working human worker could do. And again, I'm rather skeptical that we're going to get there very, very quickly. Um, but actually, for a lot of people, AGI means a lot more than that. I mean, and actually me included. I mean, I think, have we really reached artificial general intelligence if we don't have AI that can drive my car? And at the moment, we don't have AI that can drive my car or a bicycle or AI that can clean my house or clean the streets or fix the potholes on the roads in Oxford. We don't have AGI that can do it. We don't have AI that can do all of those things. So, AI in the physical world is a lot more difficult than just chatbot like AI.
Yeah, and that's exactly, well, I think it's a very important point we should mention, right? I mean, the current wave of agentic AI is fueled on the assumption that text-based interaction is essentially the only mode that matters, and as you rightly say, the physical world is very complicated. To the point that from an operations point of view, of course, I would point to variation, right? You don't have just variation in style or language or format of the text, but also you have, the physical variation, the environmental variation, the weather, right? Think about autonomous driving, right? How different roads are across countries, how different the weather is for driving conditions. Excuse me, and the like. So in that sense, we should also be very clear that what agentic refers to at the moment are text-based agents that help us in the business world. And of course, Moravec's paradox, which you know more about than I do, it's been stated a long time ago, right?
Yeah. So Moravec's paradox is it's kind of it's something which takes a while to really understand, and it's one of the things that's troubled AI even without before it had that name. It's troubled AI for decades and decades. And what it basically says is that some of the things that we find human beings find completely trivial and we don't even think about turn out to be phenomenally hard for AI. And some things which machines can do incredibly efficiently turn out to be incredibly hard for human beings. So machines, the earliest thing that people got machines to do, you get computers to do was mathematics, arithmetic, and computers can do that much, much, much vastly more quickly and accurately and reliably than any human being could ever. I mean, unimaginable orders of magnitude faster and more reliably than any human being could do. And that's something that most people, even if they don't find it difficult, they find it tedious to do. So that's an example of something that a computer can do really easily that humans find difficult. But just what we're doing now, just having this conversation, chatting in ordinary language, we probably don't even remember learning language, learning how to speak and learning how to understand. We just pick it up as we grow up. And there is a bit of formal training in it, getting taught how to write sentences and so on. But actually, most of it is just you're hearing conversations around you and having your parents talk to you, and somehow you gradually pick it up. We take it for granted, or at least those of us that, don't have hearing impediments or whatever, that are fortunate enough to not have hearing impediments or whatever. We take that completely for granted. We don't think of it as something which requires intelligence, just to follow a conversation like we're doing now. But that alone, that challenge proved so ridiculously hard for AI. People were working on that for decades. And actually, until relatively recently, progress was quite slow. And what were the magic ingredients? An old idea, neural networks, together with lots of data and lots of computer power. And that's what delivered AI that could understand natural language. But there are still many tasks, particularly stuff in the physical world, that is we find completely trivial, but is phenomenally hard to get machines to do. And that's Moravec's paradox.
Yeah. And in many ways, interestingly, right, Moravec's paradox also applies to the world of business, right? When we talk about agents, in the sense that many simple tasks within the world of business, like processing expenses or organizing a seminar, right? Things that, or travel. Oh, travel is probably the easiest of them, but the complexity or the variation of the various aspects of tasks in the business world actually probably will mean that although AI could or agents could take over some of those tasks, that it will not be economical, right? And I think that's probably what's going to be, if you think about the hype cycle, right? When agents are now at the very top of it, and if you want, take a look at Gartner's recent hype cycle for AI, what's going to disillusion a lot of people about agents is, I think, not the it's possible, but the yes, we could do it, but actually developing and training an agent to deal with all the complexities, all the variations of what the real world actually entails, it will not be worth our while, right? Excuse me. And so therefore, it's probably easier to pay someone, who has, as you rightly said, implicitly learned a lot of things like our language to do the task. So in that sense, I saw a couple of comments about the agentic world. I don't know what would the agentic world look like.
Well, we are inventing it right now, and I think the agentic world is going to arrive very quickly, and it's going to involve a vast array of agents, like the different types of agents that I talked about, some that are just doing really very, very simple tasks, but are useful sort of enablers to have there, answering routine queries, customer queries about things. That kind of thing is going to be with us very quickly. But then the idea of an agentic organization is going to take a lot longer to arrive. But where we're going to go is we're going to go to a world where entire organizations, agentic organizations without humans, are going to be entirely created and deployed by AI. So where an entire business is completely created by AI and deployed by the AI without much more than a human just saying go ahead, and do that. And what that's going to make possible is to exploit business opportunities that just may exist just for a few hours or days, where it wouldn't be worth it at the moment to create an organization, a business specifically to address those opportunities. But with AI, you're just going to be able to create a website, create the code that sits behind the website, create the blurb that goes with your business, the entire thing created by AI. That a decade ago, that's just seemed like that was science fiction a decade ago. That's going to be with us before we know it. It's going to be with us before I retire. I mean, that's an astonishing prospect.
Yeah, we have bets in the business school as to when the first zero-employee unicorn will be created, right? So the first company that doesn't have a single person employed yet reaches $1 billion valuation, and that, of course, is only possible if tasks are so specified that agents can take them over, right? And essentially beyond the high-level steer, no human input is required. Now, Teppo Fellin, a colleague, and I have had a long-standing dispute with colleagues in the strategy field as to the creativity that AI can bring to the forefront, and we remain of the opinion that fundamentally, because of the retrospective prediction-based mechanism that underpins all LLMs, that AI systems as yet are devoid of the one opportunity that humans bring, which is the theory-based experimentation, the real world saying, I know I've seen this in the past, but I disagree. This must be possible. And this is what leads to, in our view, to fundamental innovations that are beyond the training set that an AI is trained on. So, a long-winded answer. I think the agentic organization, the zero employees unicorn, is possible, but not without the human at the head, so to speak, that comes up with the idea. But who knows, right? I may well be proven wrong. And if that AGI were to arrive,
So
then
I think neither of us know exactly what it's going to look like, but it's going to come. I mean, we know we get the sense of what it's going to be, and we can both see that it's coming. And
yeah,
the one interesting thing about the AI, the rate of progress in AI, is just the speed with which ideas are transformed into reality in the AI space at the moment. The world's biggest companies pouring everything they've got into developing and deploying this technology, moving it ahead. And one of the upshots of that is it's just evolving very, very quickly. Um, so it's one way or another. I think it's going to be with us very soon. I don't know exactly what it's going to be look like, or I wouldn't be having this conversation with you. I'd be starting that company to build that AI, but it's going to be with us very quickly.
yeah. Now let's have a quick, a little bit of look into the future, a bit of crystal ball question. Which architectures, which new ideas excite you beyond what we already have?
Well, there is the big idea which makes large language models possible is what's called the transformer architecture. And this is a neural network architecture essentially that was developed by a Google lab, and they announced it in 2017. And it's basically a special type of neural network for guessing the likeliest word to appear after your prompt given its training data. So that's what enables ChatGPT and the like. And underneath all of the models that you use, Gemini, ChatGPT, Claude, whatever, there are very large scale transformer architectures. There's a lot more going on now. It's not just a transformer architecture, but there are certainly transformers there. The big question at the moment is, will we stick with transformers or will something better come along? Because
Okay.
just guessing the next word,
Yeah.
it's amazing how far we've got with that, but that's, as we've discussed, it's not really reasoning or anything. So, what's the next big idea? Will there be something which fundamentally replaces transformer architectures and does it better, maybe more efficiently without the huge scale that they have, or just is much better at doing it? So that is, well, it's not $1 million question, it's $1 trillion question. At the moment, I don't see anything that's out there. I haven't heard of anything which looks like it's going to be that architecture, but there are certainly a lot of people who think that that's what we need. So
Yeah.
that's something I think to look out for. And if the next big thing like that is as transformative as transformers have been, no pun
Mhm.
intended, then we're going to be in for another ride again. I think in AI, it's going to be another really big period of change. But the other thing to look out for is what happens in robotic AI. What happens if somebody develops a breakthrough like transformers, which really makes robotic AI possible?
Yeah.
So these are the things. Now, again, at the moment, I don't see it, but that's a really interesting question.
Right. Let me give you two candidates that I get excited about. I'm curious to see. So number one, I do, obviously looking back, right? We had symbolic AI. It greatly failed. We couldn't learn the complexities of the real world and encode them in rules. Then we had deep learning and we extracted patterns from data. That, of course, comes with the two big drawbacks of hallucination and lack of explainability. But of course, we could, of course, argue you could put them together, and you know where I'm going, right? So neurosymbolic AI does excite me because constraining or learning, extracting rules from a secondary source, like a hard-coded deterministic source, to constrain the predictions of a neural network seems to me a good compromise to bring the two worlds together. It does reduce the predictive power of the neural network, granted, because of course we are constraining how close it gets to its training data because we put rules in place, but equally it overcomes some of the core, the key issues. I don't know. Too niche to be the next revolution.
It's one candidate, and a lot of people are excited about the idea, and I can see the logic of it. There are some people, I think Jeff Hinton is, he's one of the key drivers behind this technology, Nobel Prize winner, Turing Award winner, really for the work that he did back in the 1980s on a stab, making neural networks viable. He, I think, is very skeptical. I mean, he just doesn't believe you need the symbolic at all. He thinks that the neural is just the way to go. So I can see the logic of it. I haven't yet seen any killer applications. I haven't seen anything completely convincing that really says you just couldn't do this otherwise. Look, we can do this amazing thing, and it just wouldn't have been possible if we hadn't had a neurosymbolic architecture. So the jury's out a little bit. I mean, I see the logic of it. I haven't
Okay.
seen the killer demonstrations yet. They may be out, but I haven't seen.
Let me give you my second candidate, and of course, this is on the back of Jan LeCun's, recent, success in raising funds. World models, world models that engage in self-supervised learning in the real world. They're multimodal. You mentioned that certainly before, and I agree that learning just from text most likely is too limiting in future. I can't see how we would, given that we struggle already with the compute needed, for text-based models even. But nonetheless, the idea certainly seems to excite a lot of people, not least people, who have the deep pockets and want to invest. I don't know. What do you think? World models, the next better candidate?
Well, it's another idea, and it's really about. I mean, a world model is really about trying to be able to predict the consequences of your actions and understand the way that the world is. And it's a question which is exercising a lot of people in the community at the moment. What might that look like? Um, do we need it? Again, I think the jury is out. Some people, as you mentioned, Jan LeCun very, very strongly believes that we do, and that's what his latest startup company is trying to do, which has already received multiple billions of investment. It's not completely clear to me that we really, really do need world models, or that the way that they're going about it. I mean, one interesting question is always to look back at the brain, and that you may imagine, because neural networks were originally inspired by what we see in the brain, that actually AI is kind of an implementation of that. That's not the case at all. But nevertheless, the brain can be a very useful primer for ideas in this space. And I wonder whether we might get some insights from the way the brain works, from the way the brain understands the world. And I doubt it's as simple as a world model. I think it's probably a lot more complex than that.
Yeah, fair enough. I mean, the intrinsic logic that appeals to me is to say that the human brain still is attached to us as a physical, bag of water with a couple of bones in it that move around in the physical world. Well, we do get feedback as to what the rules of physics are, and we certainly learn by understanding our actions within the environment, right? And that's, of course, none of the AI systems we currently are talking about benefit from. So in that sense, the intrinsic logic of transferring how we within our physical world get feedback appeals. But I take your point. The market obviously has put some large bets on it. We'll see where that goes. But just to say, fascinating debates, for sure, lots more to talk about. And what we hope this has given you is a bit of an insight as to what we're planning to do with this program, and that is to bring all these debates out into the open, to not just universally sort of promotes the hype in agentic, but also to show what the conditions are for agentic, for example, to make sense from a business point of view. And a couple of questions I browsed through were talking about the quality of the data, and agents for sure are not a magical remedy for having poorly, curated data or dispersed data within organizations. So also just to ground it in reality is to say, what is the business case for an agent? Because it's not the case that it will magically deal with broken processes, as did none of the other technologies, digital technologies that we've seen in the past. And also great questions. One just stuck in my mind here by Anna about entirely new ways in which governance has to work. And clearly, if we were to get to even something as close to an AGI, we would need entirely new governance structures. But even for something as simple as an agent that has access to critical resources, we need to rethink the governance, because the level of oversight changes from in the loop to on the loop, and that has ramifications. Yeah. With that, I think we are at the hour. Michael, any final words, please?
No, well, as I say, we developed the original AI executive education program in the business school some time ago now, and we've had great feedback from the students that have sat that course, and many of them have contacted me via LinkedIn to say how much they appreciated it and how useful it was. But the world has moved on, and we were really excited to develop this new program. And if you want to understand what generative AI really is and what agentic AI is, if you're feeling mystified about these things, this is what you need to do. So we really hope that you'll sign up. We think you'll get something from it.
Yeah, great. With that, it's been a real pleasure. Thanks for joining, and we hope to see you on the program. The first one starts in May, and depending on a demand, we certainly will put on more iterations throughout the year. With that, goodbye. Thanks.